All right, this is the final exam review. So we'll start off with number one. Number one, we need the domain of this expression here, x squared minus x minus 12 over x squared plus 5x plus 4. So the idea is for the domain, we can't have any negatives inside even roots. There are no roots. We don't care about that one. Rule number two is we can't make the denominator 0. So we have to make sure that x squared plus 5x plus 4 is not equal to 0. So the nice thing we could do with this is factor it. X plus 4, x plus 1. 1 times 4 is 4. 1 plus 4 is 5. Neither of those is allowed to be 0. So x plus 4 is not allowed to be 0. So x is not allowed to be negative 4. X plus 1 is not allowed to be 0. So x is also not allowed to be negative 1. Those would be the numbers that would make the denominator 0. So the answer is all real numbers, but x is not allowed to be negative 1 or negative 4. Now, if we want to check it out on the TI, we could actually plug in the thing we factored and find the zeros for that one. But I'm going to plug in the original. So I'm going to do x squared minus x minus 12. Let's get rid of those ones. So we can do a fraction. So x squared minus x minus 12. And then the bottom, I think, was x squared plus 5x and then plus 4. And we can graph it and we can kind of see, okay, yeah, it looks like at negative 1 there and negative 4, it looks like there's some asymptotes there. If I'm a little unsure, I can double check the table. I can kind of scroll in the table and see, okay, yeah, negative 1 and negative 4 give me some errors. So negative 1 and negative 4 are going to be the places where this thing does not exist. If you remember back from the fundamental theorem of algebra, since it's an x squared on the bottom, we know that there has to be either two answers, one answer, or no answers. Since we got two, we know we got everything. So there's nothing hiding anywhere else like off screen. That's number one. For number two, we need to solve this equation. So to do so, I'm actually going to factor out this side. So I get 1 over x plus 3 plus 1 over x minus 3 equals 6 over x minus 3, x plus 3. Because again, this is a special factor. This is a squared minus b squared, so it becomes x minus, or a minus b, a plus b. And now we just play what's missing. So here I see I have x plus 3. I need the x minus 3. So I'm going to multiply both sides by x minus 3. Here I'm missing the x plus 3, so I'll multiply both the top and the bottom by x plus 3. Now that all the denominators are the same, they're all going to cancel out. So this just leaves me with, these, which I'm going to distribute. So I get x minus 3. Distribute this 1, plus that parentheses 2, plus x plus 3 equals 6. I can combine like terms. X plus x is 2x. 3, and then negative 3 plus 3 is 0. So 2x equals 6. We divide both sides by 2, and we get x equals 3. Pretty quick, but there is one other thing we got to do. We got to double check to make sure that we actually can have 3 as an answer. So we have to check the restrictions. So the first restrictions for the first fraction. So x plus 3 cannot be 0. So if I subtract 3, x is not allowed to be negative 3. All right, so far so good. I check the second restriction. The second fraction, x minus 3, is not allowed to be 0. If I add 3, I found out that x is not allowed to be 3. So it turns out this answer is actually extraneous. So there is no solution to this one. So because we got rid of it, the answer is no solution. Again, if we want to double check this one, we can throw this one into the graphing calculator too. It's going to take some time to type in just because we got these big fractions, but we'll go for it. So we got 1 on top, and then we have x minus 3, and then plus, oh, that's not where we're going to go, plus. Second big fraction, we've got 1 over x plus 3. Then we have an equal sign, so that means I need to go to y2 because I want to see both sides. I want to graph both sides of them. On this one, we have to do another fraction, and this time we had 6 over x squared minus 9. All right, now if we graph this, again, we can kind of see the red and the blue. That looks like they kind of match up. at one place, which would be the answer, which doesn't really look like anywhere. So up here we can see they're clearly different. Here we can see they're clearly different, but they're getting closer. So somewhere around 3. Here they're close, but the blue one's above the red one. So 3 would be where they should probably be the same, but we can see that there is the asymptote there. So we can see that there's going to be no solution. So we can double check that with the graph. All right, for number 3, graph of x, y equals 15 is translated 5 up and left 3. What's the equation for the translated graph? I want to divide both of these by x. So I get y equals 15 over x. And now that looks exactly like the rational functions that we did in class. So for the translations, here we have 5 up. So I'm going to do plus 5 on the end. We'll just put a plus 5 on the end. I got to go left 3. So instead of having x, I'm going to have x plus 3. And that's actually it. And that's my final answer. So it's just a translation question. Again, probably not the best one to graph because we'd have to follow the asymptotes, but we could. We could graph 15 over x and see what it looks like. So we'll go ahead and do that. Another fraction. So 15 x. And then the other one is going to be what we think the answer is. So we predicted the answer was going to be 15 over x plus 3 and then plus 5. So if we graph it, so again, it's kind of hard to see with the blue and the red, but remember, when we're doing the rational functions, we always want to try and follow the asymptotes. So let's zoom out and see if that makes it a little bit easier to see. And that does make it look like it's a little bit clearer. So we can kind of see, I guess we might use the pointer. We can kind of see like here and here, we can see that we're going up and to the left. So that does make sense. And it looks like we're going left 1, 2, 3, yep, and then up. Yeah, it looks like it's about 5. So that looks pretty good to me. We could really double check with the table if we want. So the interesting thing here is we got that error at -3. And there it is at 0. So we can see those asymptotes, because again, we want to follow those asymptotes. That asymptote did go back 3. That did go to the left 3. So that makes sense. And then if we pull up these points, if I go back 3, so from 5 to 2, I am going up 5. So we could really check it. It's a little bit hard to double check in the graph, but it is possible. So that's what we got for that. All right, for 4, which graph has a horizontal asymptote at 2? Select all that apply. That's going to be this one. We've got plus 2 on the outside. This one would be -2x divided by x is -2. So that's out. We have to be just regular 2. This would be 0x's over 1x, which is 0. So that one's out. And then 2x over x is 2. So that one is in. So those are the ones that we want to pick. Again, to double check them, we just have to graph them out. I'm going to graph y equals 2 over x plus 2. So let's clear that out. And we got 2 over x plus 2. I'm going to hit zoom in 6 because I want to make my graph look normal again. That one clearly has the horizontal asymptote at 0. So we know why that one's not right. Let's look at the other one that's not right first. So -2x over x minus 2. So -2x over x minus 2. So the other one that's not right, you can see again that horizontal asymptote's at -2. It's down here, and it's not at 0. But we want it to be at 2. All right, so 2x plus 1 over x minus 2. There's 2x minus 1. And when we graph that one, we see the asymptote's up at 2, so that looks pretty solid. And then for the last one, 2 over x plus 2. So 2 over x, and then after that, we get plus 2. All right, and if we graph that one, again, we see the asymptotes there. So we can double check with the calculator. You can see that was about 3 or 4 times as slow as just doing it by hand. But if you're nervous or if you just want to have the security of double checking, you can double check them all with the calculator. All right, number 5, we can solve this equation. We can see we have x squared, so that means we want to throw everything on the same side. So I'm going to minus 2x and minus 24 for both sides. X squared minus 2x minus 24 equals 0. We can factor this. It's kind of quick. We see that we've got to multiply to negative 24. That's 6 and 4 is one of the options. If I want to double check for the adding, negative 6 plus 4 is negative 2. So that works out. We'll use the zero product property to set each of them equal to 0, just like when we did the restrictions from before. So we get x equals 6, x plus 4 equals 0, minus 4 both sides, x equals negative 4. And we got both of the answers. So in this case, it's just a regular quadratic. Since the domain's all real numbers, you're not going to get any extraneous solutions. Again, double check. We just throw in the calculator, x squared, and then 2x plus 24. So up here we have x squared, and then 2x plus 24. All right, so we graph it. We can see, all right, well, they don't look like they connect, but again, we can kind of guess that, yeah, that red line is going to intersect the blue parabola. So let's zoom out. Let's just see what it looks like. And it's like, okay, so yeah, they cross twice. So far, so good. We got 2 answers. Second calc, find me the intersection. I want to be on the parabola. I want to be on the line. Tell me the answer. Negative 4. We got negative 4. To get the other one, we're going to do second calc. Number 5 again for intersect. First curve is the parabola. Second curve is the red line. Guess. Now again, we got 6 as our other answer, so I'm going to guess 6. And yep, that works out. They do intersect at 6. And that gives me the one that's all the way up on the other side. So instead of getting just the 1, I told it to try and guess something around what I think the answer is. So again, if you didn't know, you probably would guess something like 4, something over here, and it'll then lock on to 6. But it does verify the 2 answers. So that's pretty good. All right. For number 6, for this polynomial, which of the statements is true? Select all that apply. So before I select anything, I want to put it in standard form. I can see even one of the questions is asking about standard form, so let's do it. Standard form means you have to go degrees, so highest degree first. So here I've got a 7, so that goes first, negative 5x to the 7th. Then I've got 4 is next, so plus 3x to the 4th, and then 6x is last, plus 6x. So right away I can see, yes, this is correct because it is the polynomial in standard form. Binomial is not true because I have 3 terms. A binomial only has 2 terms, so this is a trinomial. So this is wrong. Next, we see the degree of the binomial is 4. Degree always goes with the highest exponent. So in this case, the degree is 7. 7 is not 4, so we're not going to pick that one. And then part C, the leading coefficient is negative 5. If I look here, that's the number that's out front in standard form. So I'm going to pick C. And then we're done. Nothing we can do with that one for the TI calculator. You just got to do it by hand because it's all definitions. For number 7, R varies inversely with X. So right away, I'm going to write down the inverse equation, Rx equals K. If R equals 12, and when X equals 2, so this lets me find that 24 is K. So I know that R times X has to be 24. What is the value of R when X equals negative 3? So R times negative 3 equals 24. Divide by negative 3. R equals negative 8. And we're done. Again, nothing we can really do with the TI calculator unless you wanted to like type in 12 times 2 or 24 divided by negative 3. That's about it. For 8, describe these transforms to go from 1 over x to 2 over x minus 3 plus 2. Plus 2 on the outside, we're going up 2. Minus 3 with the x, we're going right 3. And that's the entirety of the question. Again, if we want to double check it, we can double check it. So we got 1 over x. Is what we're starting with. And then we are going to, I forgot, is it 2? It is 2 over x minus 3. Over x minus 3, and I believe it was plus 2 afterwards. We got to zoom 6. We got to go back to normal. All right, and again, it looks kind of difficult to tell what's happening with the graph. So it looks a little bit easier, I think, with the table. So again, we see the error, so we want to follow the asymptotes. So we got to find out where our other error is. That's right there. So we can see we went from 0 to 3, so we went right 3. Picking a convenient point, let's just go down 1. So see how we went from 1 to 4. We go up 2. So let's see, if we go right 3, we got to go from 1. We got to go down more. There we go. Oops. All right. So 1, we can go up 2, and then we're all set. So it looks like we're pretty good there. All right. So that's what we got. Not too bad. Again, if we keep scrolling down, we can see that we start getting the fractions to pop up. But that's what we got. Oops, wrong button. All right. So that's it. That's what we got. So for 9, simplify the expression, cube root of 27 x to the 12th y to the 6th. So the idea here is we want to split it up. Cube root of 27 times cube root of x to the 12th times cube root of y to the 6th. So we see that we have an odd number. So for odd, that means there's going to be no plus or minus in this one. So we're just going to do cube root of 27, which is 3. For these ones, we're going to convert them into fractions. So it's our inside divided by the index. So 6 over 3. So final answer, 3x to the 4, y to the 2nd. And that's about it. So that's all we got for 9. If you really want to double check it, you can graph this one in y1, your answer in y2, and they should match up perfectly. For 10, simplify the following. So here we've got the square root on the bottom. We don't want the square root on the bottom, so we're going to multiply by the conjugate. Oops, that's 2 plus radical 3. And then we're going to distribute along the top for 12 plus 6 radical 3. On the bottom, we're going to quickly multiply because we know that we've got a minus b times a plus b. That's the whole reason we do this. We get 4 minus 3. 4 minus 3 is 1, so the final answer is 12 plus 6 radical 3. And that's it. If we wanted to go the long way to get to this red part here, we can. We would do 2 minus radical 3 times 2 plus radical 3, and then we would double distribute from here. So 2 plus radical 3 minus radical 3, 2 plus radical 3. We'll double distribute here. So 4 plus 2 radical 3 minus 2 radical 3 minus radical 3 squared. Those will cancel. Square root and squared cancel. And that gives us the 4 minus 3 that we have right there. So again, if we want to go the long way, you can. Not really anything you can do on the calculator on this one either. So that's all we got for 10. For 11, it says y equals radical x has been translated to the left 5 and down 1. What's the equation of the translated graph? All right, well, if we're going to the left 5, that means we want to add 5 inside with the x. If we're going down 1, that means we want to do minus 1 on the outside. And that's it. Again, it's another one that if you want to throw it in the calculator to see, you could throw it in the calculator to actually see it actually move. But that's what we got. And that's it for 11. For 12, graph f of x equals radical x plus 2. So if you want to do it with the transforms, you can see this is just going to go to the right 2. Usually we start at 0, 0. Since we're going to the right 2, I'm going to start to the right 2. And then 1, 1, and then 1, 2, 3, 4, 1, 2 are common points. So we'll go ahead and we'll get our graph. And that'll be about it. Again, throw it in the calculator if you want to double check it. In this case, it's just x minus 2. So radical, it's not a radical. X minus 2. We graph it, and then there it is. If you want to grab the points, again, the table will tell you all the points real quickly. So the points that I plotted were 2, 0, 3, 1, and 6, 2. So again, those are the points that I actually drew with the circles. So you can use the table to get those points if you don't want to have those quick points memorized. But that's it for 12. 13, given f of x is 3x squared minus 2x plus 5, g of x is 3x minus 2. We got to find f times g. So this one is just a really big distributing question. Since we want to multiply them, we're going to put them next to each other like this. And then we just have to do a lot of distributing. So we'll do 3x squared times that piece times 3x minus 2. We're going to do negative 2x times this piece, 3x minus 2. And then we're going to do 5 times this piece, so plus 5, 3x minus 2. All right, and then from here, like I said, we just distribute a whole bunch. 3x squared times 3x is 9x to the third. 3x squared times minus 2, negative 6x squared. Minus 2x times 3x is minus 6x squared. Minus 2x times minus 2 is plus 4x. 5 times 3x is 15x. 5 times negative 2 is negative 10. And then we combine all the like terms. So 9x cubed just stays as 9x cubed. Here we gotta be careful. This is minus 12x squared. It's not 0. Looks like it might be 0, but it's not. Here we got 4x and 15x for 19x. And then minus 10 is hanging out all by itself. Nothing to combine with there. And so that's the final answer. Again, if you want to double check it, you can graph the original, so up here in black that I have, and graph the answer and see if those do match up on the graphs. For 14, we got f of x is square root of x plus 4, g of x is 2x. We got to do f of g. So remember, for the composition, we're going to take g, plug it into the x for f. So the expression is really just 2x plus 4. So that's it. That's all there is for part A. What is the domain of f of g? So again, we can see we have a square root, and remember the rule is that we can't have negatives in the square root. So that means that 2x plus 4 has to be greater than or equal to 0. So what we want to do is effectively solve this inequality. So we're going to get rid of the square root with the squared. 0 squared is just 0. We're going to subtract 4 from both sides. So 2x is greater than or equal to 4. Negative 4. We're going to divide both sides by 2. So we get for our answer, x is greater than or equal to negative 2. So again, that seems a little bit weird that we could put negatives inside here, but if we think about it, if we try negative 1, like 2 times negative 1 would be negative 2. Negative 2 plus 4 would be regular 2, and it's okay. We could do square root of regular 2. So that's why we get this. That's why we're allowed to have this as our domain. All right. 15, if h of x equals 6x minus 5, what's the equation for h inverse? So the idea for the inverse, and just remembering that this is the inverse notation, is we're going to swap the x and the y, so 6y minus 5, and then we try and get the y by itself. So plus 5 both sides. We'll divide both sides by 6, and that's going to get the y by itself. So our final answer is x plus 5 over 6 is h inverse of x. Because remember, h inverse of x is the y in this case, so we're all set for 15. All right, for 16, we got to solve this one with the 2 square roots. Again, if I see this, I'm probably just going to go ahead and graph it and get the answer with the graph. I'm probably not going to go ahead and solve it by hand. So I'm going to do it both ways, just so you can see it both ways if you do want to do it both ways. But I'm going to do it with the calculator first, since that is probably the way that I would do it if I saw the question. So square root x plus 1. That is not a square root. And then I think we had plus 1 after that. I have to double check that. Okay, yeah. And then square root x plus 3 is down here. All right, then we're going to graph it, and we're going to see if we can see where those connect. And yeah, it looks like they connect at like -1. So I'm going to hit second calc. I'm going to find the intersection. First curve, blue curve, so I'm good there. Second curve, red curve, I'm good there. Tell me the answer. It's not -1, negative 0.75. So it looks like that's going to be my result. Since, again, this is the preferred way to do it, I am actually going to take a snapshot here. Oops. And, no, wrong button again. There we go, there we go, there we go. Just take a snapshot of that intersection, because, again, this is how I would do the problem. So I want to send it to current page. So this is what I get. Now again, 0.75 is a clean decimal. Since that's a clean decimal, that's just 3/4. I am okay with just having this as the final answer. So my answer is just going to be the x equals 0.75, negative 0.75. It is not the y coordinate. The y coordinate would be wrong. So any mention of 1.5 would make this an incorrect answer. All right, so now let's see how we would have to do it if we wanted to do it by hand. So if we do it by hand, I mean, we have 2 square roots, so that's not good. The nice thing is, though, that they are on opposite sides of the equal sign. So if they weren't, that would be the first step, because what we have to do is square both sides to get rid of the square root. Now on this side, we're actually going to multiply this out. Now again, you could multiply it out really quickly. If you wanted to go the long route, this would be square root x plus 1 times square root x plus 1 plus 1. Other side, I'm just left with x plus 3. So that side's pretty nice. So what I've got here is I've got another double distributive question, though. So I've got to do square root x plus 1 times square root x plus 1 plus 1. Then I got 1 times all this. So plus 1 square root x plus 1 plus 1. All right, now when I double distribute, square root x plus 1 times square root x plus 1 is x plus 1. So square root x plus 1 times square root x plus 1, the square roots would cancel out because I'm squaring it. I'm going to write that. I might as well just go with one extra step. All right, so it's just that squared. Square root x plus 1 times 1 is square root x plus 1. In red, 1 times square root x plus 1 is square root x plus 1. 1 times 1 is 1. I still have x plus 3 over here on this side. All right, so now I'll cancel out the square and the square root, so I get x plus 1. I'm going to combine like terms here, so plus 2 square root x plus 1. And I'm going to do minus 1 both sides here, equals x plus 2. All right, well, I'm not quite done because I can still simplify. I'm going to minus x and minus 1 both sides. So now I'm down to 2 radical x plus 1 equals, well, x minus x is 0. 2 minus 1 is 1. I can divide both sides by 2. I'm actually going to come all the way back up here then. So that's going to cancel the 2's out. So I get square root x plus 1 equals 1/2. And the reason I wanted to come all the way back up here is because look what I'm going to do next. I'm going to square both sides again. I just have to repeat what I did the first time. So square root and squared would cancel out. So I get x plus 1. 1/2 squared is 1/4 because 1 times 1 is 1. 2 times 2 is 4. All right, minus 1 both sides. So I get x equals negative 3/4. And look at that. We get the same answer. So yeah, you can do it by hand. It is a lot longer by hand. No way around it, but it is possible to do it by hand if you don't want to use the calculator, or if you just don't trust the calculator, that's fine. You can go ahead and do it by hand that way. But that's how you do it. We square both sides twice is kind of the key there. So that's what we got. Now, since we did square both sides, we do technically have to double check this. Again, my way of double checking turned out to be with the calculator. If we do plug them in, we would get negative 3/4 plus 1 plus 1 equals square root negative 3/4 plus 3. I do have to make sure that this works. It looks like it's going to work because when I simplify this, this is square root 1/4 and square root of, so this is 9, that's 12/4. So 12 minus 3 would be 9/4. I look pretty safe because I don't have any negatives in the square root. Usually that's going to be the key that will show you that this is a no solution. If we do these square roots, square root of 1 is 1, square root of 4 is 2, so 1/2 plus 1. Square root of 9 is 3, square root of 4 is 2. And yeah, 1/2 plus 1 does equal 3/2. So we can double check it by hand as well too. But that's 16. Again, if you do it by hand, pretty long. Oops, let me get the whole thing on there. If you do it by hand, pretty long. If you do it in the calculator, kind of short. All right, for 17, we need to identify the y-intercept and the asymptote. So the y-intercept is pretty nice. We plug 0 in for x. We get 2. The asymptote, we can see we're not really adding or subtracting anything onto the end here. So the asymptote is going to be y equals 0. So again, the asymptote is always a line. It's never a number. So you cannot put 0. 0 is not a correct answer. This would be one to double check if you want with the calculator. We can put it in to parentheses 1/4 to the x power. So to the power of x. And again, we just get the regular, okay, yeah, that looks pretty much like an exponential. Hit trace, you can see 0, 2 is the y-intercept. It's very clearly leveling off at 0, at y equals 0, so we know that's going to be the asymptote. For 18, got to find the average rate of change from -1 to 1. So again, we're going from here to here, so we're just going to use our average rate of change formula, which is f of b minus f of a over b minus a. So if we plug those in, this is going to be a f of a, because again, we've got a and b here. So this is b f of b. So we've got 6 minus 1.5 over 1 minus -1. So that's 4.5 over 2, which I think that's fine. If we do simplify that, what was that going to be? 9/4, right? That looks pretty good. All right, so that's all we got. That's it. Again, you can do this however you want. You can use the slope equation. You could even do rise over run. If we look to see how much we rise, it's a half, 1, 2, 3, 4. And if we run 1, 2, so we can see we still get the 4.5 over 2. So that's about it. All right. Sounds good. For 19, colony of ants has a population of 520. It's decreasing at a rate of 2.7% per year. Write the decay function for the quarterly decay rate. Again, it's going for a quarterly decay rate, so I'm just going to start with the interest rate equation. So that's going to be y equals a parentheses 1 minus r over n to the nt power. The reason I got a minus instead of a plus is because we're decaying. So the decay makes it a minus. When we plug everything in, so A is our starting population, that's 520. 1 minus is just going to stay as 1 minus. The rate here is 2.7, so 0.027. We're going quarterly, so quarterly would be 4 quarters in a year. And then t just stays as t. Again, you can make it an x if you would rather have x than t, but that's it. Part B says, what's the y-intercept in context? So the y-intercept is the 520. So in context, that means we start with 520. And in context, that would be ants, because our problem deals with ants. So that's what we got. Again, graphic calculator, not too helpful on that one. That's what we got for 19. That's it. For 20, we got to get the inverse of this function. So again, inverse, first thing we do is swap the x and the y. So x equals 5 to the y. Now we have to get the y by itself. So to get rid of the 5, we're going to do log 5 of both sides. Or just use the definition and say that log 5 of x is equal to y. Since y is by itself, that's our final answer. Log base 5 of x is the inverse. So we aren't really given a function, so I guess we could say y inverse. But that's it. So we're all set with that one. Again, you can do this however you want. I did it with the definition. I kind of talked through how you would do it with the log, where you do the log of both sides. If you want to use the snail, you can use the snail too. Log 5 of x equals y. So that gives you the same answer. 21, we got to get the solution for this equation. So again, I'm going to go ahead and just snail this. Seems like it's the easy thing to do. 3 to the -1 equals 2x minus 3. 3 to the -1 is 1/3. So I'm going to add 3 to both sides. So that's 3/3. That's 10/3 equals 2x. Divide both sides by 2. So that's going to be 5/3 equals x. And there's the answer. Again, if you don't want to do it with the snail, do not have to do it with the snail. If instead you would rather say, well, I think I want to do with log 3 of 2x minus 3 equals -1. You could go 3 to the power of each side. So 2x minus 3, and then 3 to the -1 is 1/3. And then we're kind of back into the same flow. We're just going to do the same procedure. So add 3 to both sides. So 2x equals, that's 10/3 again. I guess we'll be fancy here. Just multiply both sides by half instead of divide by 2. Either way, we still get x equals 5/3. And if we do want to use the graph, we could also graph it. So log base 3 of 2x minus 3. So in the math menu, we got to go to the log base. So there we go, log base 3 2x minus 3. And then we want this to equal -1, so we'll put -1 on that side. We'll graph it, and we can see, all right, that looks like that should be about right. Second calc, number 5 for the intersection. Now, if you look down here, there's no number for the y, so I can't pick the blue one yet. I have to scroll over to get onto the blue curve. All right, now I'm on the blue curve. I'm on the red curve. Tell me where they cross, and I get 1.667. Now, 1.667 is not the answer. That's a decimal approximation. The answer is 5/3. So you can't use the calculator unless you know that that's 5/3, which if you do, more power to you. You can't use the calculator, just write down the decimal and expect that to be correct. So the correct answer is the fraction. The correct answer is not the decimal, because the decimal would be a rounded decimal. It doesn't ask what is the approximate solution. It wants what is the solution. So it has to be exact. All right, number 22. We got our function. What's the value f inverse at x equals 11? So f inverse at x equals 11 is another way of asking where it is for f of x, y equals 11. Ooh, that's a really bad 11. So if I look at my graph right here is where y is equal to 11. So x equals 2. So the answer is 2. So we're all done. That's all you have to do for that one. If you really want, you can actually find the inverse. So if you really wanted to, you could start back at the beginning and say, all right, let me try and work my way through it and say x equals 1/2 4 to the y plus 3. So minus 3 both sides equals 1/2 4 to the y. Multiply both sides by 2. So we get 2x minus 6 equals 4 to the y. Then we can do log base 4 of both sides. To cancel out the 4. So we could find that log base 4 of 2x minus 6 is equal to y, or equal to f inverse of x. And then we need to find out what's happening at x equals 11. Oops, we'll scroll up actually. So we're going to plug 11 in for this x. So we'll do log base 4 of 2 times 11 minus 6. So log base 4 of 22 minus 6. Log base 4 of 16. And if we want, we could plug this into a calculator. We could also go ahead and snail it again to say 16 equals 4 to what power? So 2 is y just by logic. We also end up with 2 that way. So again, you could go the long way with that one if you don't want to use the graph. That's how you would do it by hand. Again, if you don't want to solve this by hand, you could put log base 14 or log base 4 of 16 into a calculator. For 23, find the equation of the inverse. So we're basically doing like what we just did by hand, except not as many steps. We got x equals log base 4 of 3y. We're going to do 4 to each side, 4 to the power of each side. So our exponentiation is going to cancel out our logarithm because they're inverses. 3 to the y, divide both sides by 3. And then we're done because y is going to now be by itself. So 4 to the x over 3 is equal to f inverse of x. Now, no one would probably try and simplify 4 over 3, but in case this was like a 6, remember we would just leave it as 6 to the x over 3. We do not simplify these because order of operations says we would have to do the exponent first. So exponent before multiply or divide. 24, expand the expression. We're just going to use our rules. So rule number 1, multiply is going to turn into addition. It's a really bad way to write that. We're using the product rule. So this is going to become ln of a to the third plus ln of 1 over b squared c. Next rule we're going to do is we're going to do the quotient rule. We're going to turn division into subtraction. So ln of a to the third plus ln of 1 minus ln of b squared c. And now this one's a little bit odd because I see now I have another multiplication. So I'm going to come back and use the product rule one more time. So I have ln of a to the third plus ln of 1 minus ln of b squared plus ln of c. All right, and then third rule is the power rule. So power rule, we're going to take the exponents and rank them down to multiplication as coefficients. So we're going to go ahead and bring that out front. We're going to go ahead and bring that out front. And that's all we got for that part. So 3 ln A plus ln1 minus 2 ln B plus ln C. And then step 4, the final step is to simplify. So if we're going to simplify, 3 ln A doesn't simplify. ln of 1 does. ln of 1 is 0, so it turns out we don't need anything here. We'll go ahead and get rid of that plus sign. So minus 2ln, 2lnb. Because I can go ahead and distribute this minus sign to both pieces, minus ln of c. And that's the final answer. So nothing you can do with the calculator here, unless you want to double check that ln of 1 actually is 0. So that's what we got. So if we follow the rules like we did in class, that one's actually a little bit longer than normal, just because we have 2 of them to do. Some of you, though, in class saw like, hey, I see the division, I want to do the division first, and that's totally allowed. So if the first thing you saw is I'm going to turn this into, instead of ln of a to the third plus ln of 1 over b squared c, you could turn that into ln of a to the third minus ln of b squared c right away. So if you saw that right away, you could do that. That would also be okay. It kind of skips a couple of the steps, so it makes it a little bit shorter. But that is a little bit more advanced because it doesn't follow them exactly like we did in class. But you are allowed to do that. Oops, too far. 25, we got our geometric sequence. So remember, for a geometric sequence, that's multiplying every time. So first we have to do the recursive definition. So a of n is equal to a1 when n equals 1, and r times a to the n minus 1 when n is greater than 1. So if we fill in what we know, a1 is our first term, that's 2. R is how much we're multiplying by. We can see that that's 4. If we weren't sure, we double check. 128 divided by 32 equals 4. So that's 4. And then a n minus 1 stays as a to the n, a sub n minus 1. N equals 1, n is greater than 1. And we're all set. That's all we got. Part B, we have to do the explicit definition. For the explicit definition, we would say a sub n is equal to a1 times r to the n minus 1 power. And again, the whole idea here is we're just going to plug in with what we know. We already figured out a1 was 2. That's what we're starting at. We figured out r, what we're multiplying by every time, was 4. N minus 1 power stays as n minus 1 power. For part C, what's the sum of the first 5 terms in the sequence? A ton of ways you could do that. Since I already gave you 4 terms, I'm guessing most people are just going to multiply 128 by 4 and then add all of them up. But that's not very fun, so we're not going to do that. We're going to use sigma because we want to go from 1 to 5 because we got 5 terms. The reason sigma is useful is because we already have the equation. We already had to get the equation in part B. So we're just going to do 2 times 4 to the n minus 1 power. Because we know the calculator can just calculate this. I think I want to do it this way. So let's go ahead and let's get out of the graph. So we're going to go get sigma. That's our summation. This calculator is nice, has a little sigma by it. We want n to go from 1 to 5 for the formula 2 times 4 to the power of n minus 1. And we get 682. All right, seems reasonable. Yeah, okay, let's take a picture. So let's see if that matches up. Let's see if we did that correctly. That's a big sigma. So if we do want to add them all up by hand, I do need to figure out what 128 times 4 is. 128 times 4, 32, 8, 11. That makes sense. That's not a 1. That's a 1, 512. That makes sense. Think about computers. You get 512. All right. So if we add them up, 2 plus 8 is 10. That's pretty quick. 128 and 152 or 512. I think we can add those up somewhat quickly. So that's 130 and 510 is 640. So that gives us 650, and then we got the 32 is 682. Yeah, okay, so if we add them all up manually by hand, we also can get the same answer. Not as fun as sigma. I probably would not recommend using the summation formula just because there's only 5 terms here, but the summation formula would be your other option. All right, 26 for theta is 2 pi over 3. We have to find sine and cosine. So since we've got 2 pi over 3, we're going to go ahead and sketch this out. It's not a great one, but we'll deal with the circle. So remember the idea here is we've got 3 on the denominator. 3 times 2 is 6. So I want to make 6 slices. These are going to be way off. That's a bad circle. That's all right. Okay, so that's what we got. We want to find our second slice. So let's label 0, 1, 2, 3, 4, 5. Second slice is right here. If we draw the triangle, all right, we can kind of see that I didn't do too bad because we can see this side is shorter than this side, which is the whole point. Sine, remember sine is the y value, so sine is going to be square root of 3 over 2. It's the long side and it's above the x-axis. Cosine is going to be 1/2, but it's going to be negative because it's the short side and it's on the left of the x-axis. It's left of center. And we're done. That's it. Look at that. If I want to double check, I mean, you could just type them in. Sine of theta, second alpha, 2 pi over 3. Okay, how about cosine? Cosine of 2 pi over 3. Okay, well, that one we can tell is negative 1/2. The other one, though, again, that 0.866 is not the right answer. So that would not be correct. You have to know that it is square root of 3 over 2. Or if you think it's square root of 3 over 2, you can always just double check and see, all right, well, wait, what is square root of 3 divided by 2? So square root of 3 over 2 is, that's not what I want. Square root of 3, then divide by 2 is the 0.866. So we could double check to make sure that that is correct. I mean, we don't need to because we got to memorize, but you could if you wanted to. So that's what we got. Again, the decimal here is not the correct answer. The decimal would not be correct. 27, which of the following are possible measures for the angle? Select all that apply. So it looks like, to me, it's going to be easier to go backwards first, because this is 90 and 20, and so 90 plus 20 is 110, so I'm going to pick B. If I have to check any of the others from here, I'm just going to add or subtract 360. So if I go negative 110 minus 360, that's negative 470. Negative 150 is not negative 470. If I add, so that's going to be 360 minus 110 then, because 360 plus negative 110 is the same as subtracting them. I get 250. So 250 is neither of these ones either, so I think it's just B. That's all I got. I guess I'm done. I guess it's just one of them. That's fine. If we do want to double check to go around the other way, we can. We know since this is 20, this has to be 70 degrees because we have to get 90. So this is 180, and 180 plus 70 is 250. So we get the same answer both ways. Either way, not going to be either of those, because the next one I would hit would be another 360 around, which is going to be way more than those. For 28, an angle has a reference angle measuring 50 degrees and terminal side lies in quadrant 2. What are the positive, and negative angle measures for this angle? So if it's 50 degrees, we have to remember that when we do reference angles, we always have to use the x-axis. So we know that is 50 degrees. I think with this one, it's going to be easier to go forwards. Maybe. I guess forwards uses a little extra math. Maybe backwards is a little easier. So we go backwards, that's 180 plus 50. So 180 plus 50 is negative 230. If I add 180, add 360, so 360 minus 230, that's going to be 130 degrees positive. And it makes sense because this would be 90 and 40 would be 130. So that's what we got for two of our choices. Again, you can always keep adding 360 or keep subtracting 360 to also get correct answers. For 29, we got to find sine if cosine is negative 12/15 and theta is in quadrant 3. So the idea here is that cosine of theta is adjacent over hypotenuse. So that means that 12 is the adjacent and 15 is the hypotenuse. So I'm just going to come out here and say that that's 12. The hypotenuse here is 15. I need to find sine, and the idea behind sine is that sine is opposite over hypotenuse. So I know 15 because I know 15 is the hypotenuse. I know it's negative because I can see that I'm going down, but I don't know what number I have here. So I could use the Pythagorean theorem to figure it out. We'll call that A. So A squared plus B squared equals C squared. A squared plus 12 squared equals 15 squared. A squared plus 144 equals 225 minus 144 both sides. So what are we getting here? So 225 minus 144. 11, that's 7. Oh no, I don't need to subtract anything. 5 minus 4 is just 1. Good, that's what we want. All right, 81, square root both sides. So A equals plus or minus 9. And we can see that it's negative, so we're going to need the negative 9. But the negative sign, we just logic the negative signs. Don't really have to worry about it too much. And that's it. I guess we're done. We didn't really need to do the Pythagorean theorem. You can just look at that. It's a 3, 4, 5 triangle. So you can just use your 3, 4, 5 right triangles from geometry class. 9, 12, 15, because you can divide them all by 3. So that's it. That one's done. 30 and 31 says we use our two equations that we've got. For 30, triangle ABC. Triangle ABC. Hopefully I do that somewhat decently. A is 38 degrees. Little a is 20 inches, so remember little a is always across from big A. Little b is 18 inches. Okay, so that's 18 across from big B. Find big B to the nearest 1/10 of a degree. So since I've got one angle and I want to find another, I can see this one only uses one angle, so I'm not going to use that one for this question. So sine of 38 over 20 is equal to sine of B over 18. So I'll multiply both sides by 18 because I want to get sine of B by itself. And I'm actually going to put that into a calculator because I have to find it to the nearest 1/10 of a degree. So I'm going to go to my calculator. Second, y equals, so I've got 18 sine of 38 degrees over 20. And I get 0.55. Well, wait a second. That's in radians because my calculator is still in radians mode. Yes, I got to switch modes after all. So I'm going to go down, switch modes to degrees. Now remember, when we do this, one of those other questions that we did when we had to find sine and cosine of 2 pi over 3, we couldn't answer that question if we were in degree mode. Because what we have to do here is we have to then do the inverse sine. Where's my answer at? And so we get 33.64. So why is that the answer? Well, because remember, once we've gotten to here, so 18 sine 38 over 20 equals sine of B. To undo this sine, we have to do sine inverse. And that gives us our final result, 33.64, 33.6, the nearest degree. And there we go. And that makes sense. 18 is less than 20, so my answer should be less than 38, so that makes sense. And that is, again, to the nearest 1/10 of a degree. All right, 31. Since we've got 3 sides here, 1, 2, 3 sides and 1 angle, we're not going to use this one. We're going to use the other one. We have to find out how far airstrip C is from airstrip A, so we're trying to find this. Remember, these are all placeholder variables. C could be actually anything in the law of cosines. If we think about it like Pythagorean theorem, because a squared plus b squared equals c squared, C is usually the longest one. Here, C is the longest one anyway, so I mean, that's fine. The letters here are a little confusing, but the way we want to set it up is we would just say that b squared, because b is the same as c up here, equals a squared. I'm just going to call this one A because that's across from A. We'll call that one C because it's across from C. So 15 squared plus 20 squared minus 2 times 15 times 20 times cosine of angle C. Again, B and C switch spots for this picture. So 124 degrees. And again, we can see we got to be in degree mode for this one. So I want to be in degree mode for this one. I want to find out B, so I'm just going to square root both sides to get B by itself and just type this in as a big square root. So second square root 15 squared plus 20 squared minus 2 A B cosine of theta. All right. 32.72. So as long as I type that in correctly, that'll be the answer. 1520 minus 2, 1520 cosine 138. That's 124. I have no clue where that 138 came from. Oh, I know, because we did 38 in the last question. 30.99, so 31. So to the nearest 1/10 of a degree. Oh, it doesn't even say. It just says how far is it. So B is about 31 miles. Yep. Well, doesn't even tell us anything. Miles makes sense, but I mean 31. There's no units anywhere on that picture. All right. For 32, what is an equation for a circle with radius 9 and center 0, 0? So equation for a circle from geometry class: x minus h quantity squared y minus k quantity squared equals r squared. So the center is at 0, 0. That's h and k. So x minus 0 squared plus y minus 0 squared. Radius is 9, so 9 squared. So x squared plus y squared equals 81. We can simplify everything down. There we go. So that's everything we got for that one. For number 33, which of the statements about the ellipse are true? Select all that apply. So for the ellipse, again, our equation from geometry was x minus h squared over a squared plus y minus k squared over b squared equals 1. Where a is going to be the semi-major, it's going to be the x-axis radius, and b is going to be the y-axis radius. So first thing we see here is the center is negative 2, 5. We can tell that that's not true because our center here is going to be the opposite of these ones. So the center here should be 2, negative 5. Because again, we want the opposite just like everything else we've done in class. So we're going to get rid of that choice because that's not where the center is. So next we'll do with the axes. So the horizontal axis, remember that's going to be a. So if I do square root of 25, that's 5. So the horizontal radius is 5. So the whole axis is going to be the diameter. So 5 times 2 equals 10. So horizontal axis is 10 units long, so that's good. If I want to find the vertical, 16 is 4. So the vertical radius is 4. 4 times 2 would be 8. They did not ask about the vertical axis. Okay, well, that's all right. We could do that anyway. So last thing we got are the vertices and the co-vertices. So to get these, what we actually have to do is make a picture of this one. So let's see. That's probably not going to be good enough, but 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The reason I don't think that's going to be good enough is my center's at 2, negative 5, and so my center is here. So to plot all of the points I would need to, I'd have to go ahead and say, all right, I know my horizontal axis is 5 for my radius. So from here, I've got to go 1, 2, 3, 4, 5 out. So if I'm there, that's going to be at 1, 2, 3, 4, 5, 6, 7. 7, negative 5. And then I got to go back 5. 1, 2, 3, 4, 5. So this is going to be at negative 3, negative 5. All right, well, actually, that works out. Those are my vertices, so I'm good to go with my vertices. My co-vertices would be if I went in the y direction here, because the y is less than the x. So if I did that, I got to go 4. So from here, I go 1, 2, 3, 4. So that's at 2, negative 1. All right, that checks out. But I got to go down 4 also. And I think we can pretty clearly see we're not going to pick this choice because it's not at 6. This is down here at 2, negative 9. So the 6 is wrong. Now, what does this make? I mean, it does make an ellipse. So if we kind of make an ellipse out of it, we have to kind of round it and not make it look like a diamond so much. It's an ellipse. That's what we got. So there we go. All right. And I believe that's everything. That is. So that's what we got for that one. So that's the whole exam review using some of the TI stuff that you can do. So there we go.